Alright, we're back online. G'day folks, my name's Edward Farrell, and the talk I'll be going through tonight is just an intro into wireless attacks as they apply to the 802.11 space, and just getting your head around Rogue APs. So it's part of our first meetup, back thing. So I just wanted to do a bit of an introduction into the offensive space as it applies to wireless security, and also just do a bit of an introduction to what I call Rogue APs. Just by show of hands, how many people have come in from the, I guess you could say, the radio space here, versus those who come in, say, from the cybersecurity or IT and networking space? IT and networking folks. Cool. So, majority of people here have come in from an IT background or a cyber background. God knows why we went with the word cyber, but here we are. And so, I guess this was a really good introductory piece on taking people through the wireless space based on content that they already know, specifically connected to Wi-Fi spaces, but also having a bit of an understanding of IP networks, which, when it comes to everything else, can be a little bit problematic. So this is usually a good start to get some concepts around the fundamentals. So as I said, this is me. What's me? There we go.
Dash. We'll figure out a solution for this afterwards. Sorry, guys.
Stop using Internet Explorer.
Yeah, that would probably help.
So I run my own pen testing firm, and I also teach in wireless cybersecurity at the Australian Defence Force Academy as well. So this whole space is of interest to me, and I've been teaching there for the last few years. So this is something I am interested in over time, is exploring what does the wireless space look like here in Sydney, both in terms of 802.11 and other similar protocol space, but also even just from a basic RF attack surface, what's out there and what can be done. One of the things I'm really keen to do while I'm here, I'm not some thought leader standing up on stage. I'm really keen to actually expand some of my, what I would call my layer 0 knowledge. And then hopefully sometime this year actually have some decent war driving kits. So this was a bit of a concept we started building before we start buying heaps of hardware. Here's just a simple 802.11 war driving rig that we can just throw in our bag and get going. That might solve some of the waterproofing issues. Pelican case from JCar for about 10-15 bucks. So anyway, stuff I'm keen to build over time. If anyone wants to help out, chip in or do stuff. I've just started ordering all sorts of extra kit based on this first iteration. So that's a bit of a preamble for anyone that wants to have a look at setting up some Rogue APs a little bit later. If not, we can just go through it off my own laptop. So, get on what's driven this talk. Some of it really has to deal with how we think about wireless networking and wireless cybersecurity, especially around client and server cryptography. Things about war driving, things about how there's elements of what I call a two-way attack surface that a lot of cybersecurity professionals pay off. If you look at most security testing that's done, a lot of it usually focuses on issues server side, or in the case of wireless networks, access point side, whereas there's a lot that can be done against clients, and I think these are attacks and elements that we have a really bad habit of paying off. Some guy called Chad, when I was doing my war driving talk for Zigbee, thought that you could actually do it with a pineapple. Unfortunately not, and I think this is also another thing that I like doing with either my talks at the Academy or even around the communities, just encouraging that hands-on analysis and troubleshooting in order to actually understand what's taking place, and then building out your knowledge from there, as opposed to here's a flashy UI, it looks nice, but you're not really actually doing anything about it.
They have a logo now. Wi-Fi.
Whoever's doing RSA, just cut him off. So I figured also, this being our first event back, we might do good to actually have a bit of an introduction into what constitutes wireless technology, and then off the back of that, what are some wireless security concepts as they apply from an offensive state. So, it's definition of wireless. I think for most of us here in the who have actually come from the cyber or the actual physical wire space, we're now actually looking at wireless tech. So when we start looking at elements of wireless attacks from an offensive side, as opposed to just purely researching and understanding things, we look at things such as being able to do traffic captures. You think about it, this isn't now throwing in a Dropbox to plug into a network to a physical capture. Someone was complaining about finding a place to connect to around here. There's a lot of Wi-Fi pollution. There's also a lot of opportunities just to capture wall packs, and if they're just simply using a WPA Part 2 password with pre-check key, there's a good chance that we'll be able to decrypt some of that traffic. Other elements as well is direction finding. So we can actually, we talked about with some fox hunts before. The idea behind direction finding is identifying where someone is. The image I've got on screen there is the lead into the Battle of Long Tan, where you actually had an Australian Army unit called 547 Signatory that were doing direction finding against what was clearly then a much larger, much more aggressive enemy force. Unfortunately, Brigadier Jackson at the time just went, yeah, effing nerds, not interested. He was subsequently proven wrong. We can also do things such as replay attacks. So you heard me before mention with this really awesome HackRF Dropbox. If you could capture what's called on-off ping coming from, say, a remote or a garage or a security system, that can then be replayed. Impersonation is always another one as well. So common issue that they had during World War I and World War II was individuals impersonating friendly forces. Still an issue today as well. Then finally, deny as well. So being able to actually do jamming. So just something to be cognizant of there. Jamming is in fact out of all of these. Whilst they are all typically a grey area, jamming does actually come with penalties to it. Anyone know what the fine is for sending an unauthorised transmission in Australia? Up the back here?
$200,000 fine.
Close, little down. Divide by 2. TJ, don't answer, your maths is terrible. So about $125,000 it is a fine for a single instance. A little bit. I don't think you'll be able to afford a house in Sydney, but it's expensive. And the 211 standard is what we commonly know as Wi-Fi. Who actually knew Wi-Fi was invented by the CSIRO? Yeah, so, Australians actually invent stuff.
They invented some of it.
Yeah. Just give the CSIRO credit.
Eddie Lamore did some of the basic technology.
That's Headley.
Headley.
No, it is
Stand corrected.
It is Headley. No one here's seen that Blazing Suns, have they? Alright, homework. But the intent behind this was to actually go into connection of computers or devices and password for each user, and that's exactly what we're saying. So to reorientate our thought process from the OSI model, all we're really doing here is just modifying the physical and data link into the wireless space. So at a physical layer, we start looking at elements of physics. We start looking at power, direction, location, the environment. This is actually a well-built environment, so being able to achieve, being able to transmit and receive in this environment isn't as good as, say, if you were to roll this out in the middle of the desert. Things we look at here come back to accessibility, being able to identify individuals, and also accessibility elements, which of course are all part of wireless and part of the system. The data link layer, this is where a lot of the metadata sits, which is dealing with how data is actually transmitted, received, how joining and getting off networks is managed, and in some elements, authentication and access control. But of course, one of the issues we have here is the protocol itself, file virtual, where it has some fundamental issues around access control and limitations. But then we also come back to our good old CIA triad, where none of you've gone off to RSA, where we start looking at things such as, the availability of that system based on the underlying physical properties, the confidentiality of it. So can you intercept, and then off the back of that, can you decrypt? Can you actually start taking on information that's been sent, as well as the integrity of that environment as well. And I think integrity is always one of those things that we don't do as well of. We don't do as well when it comes to cybersecurity in general. And of course, beyond that, we just have layer 3 and above, which ties in with the rest of the IP stack and business as usual. So this is a really handy diagram. I had to go through Internet Archive to pull this one out again. This is a really good understanding of some of the attack methodologies out there. Big one though, however, that I've always been quite lacking in terms of information that's accessible and attacks that individuals can quite capably get their head around is this rogue access point piece just down here.
So this is quite hard to see. Can you maybe explain some parts of it?
Yes.
Yeah, of course.
What is this? The diagram for ants?
Yeah.
So if we have a look at it, we have unencrypted networks, which we can just pick off straight away. We can also connect to them as well without authentication. So immediately we can start seeing what people are doing on open guest networks. And conversely, we can join those networks and start doing attacks or playing around with those networks. What's always interesting in that space as well is has the client organization, so when we do our pen tests, one of the things I always like seeing is has the client organization completely isolated the guest network and treated it like the window that it is. If you do have a look at some of those guest networks, you'll actually often see that DNS hasn't been properly configured, or when it comes to network isolation, everyone's gone down TCP because that's really how people are going to do attacks. You can then start, doing write functions on Cisco kit because they have an isolated SNet. So web is another one. The E in web doesn't stand for encryption. The issue with web is each packet will contain an initialization vector. You can capture usually about 30 or 40,000 packets. You can actually reverse the key. So over an extended period of time, web will be quite easily cracked. It just is a matter of throwing a Dropbox, capturing about 30,000 packets, and then being able to brute force that key.
And you can stimulate it to create those packets that you capture as well.
You can. So just sending shitloads of deauth requests to achieve that. At the WPA and WPA2 encrypted WLAN space, if you can actually capture the four-way handshake between client and an access point, you can actually brute force and crack the key. So there's couple of online pieces of software that you can use for that. There's also pre-computed tables, so avoiding the name iPhone is now. So did anyone have a Netgear router that was always called Netgear?
Yeah.
Yeah, so there were pre-computed tables for passwords for devices called Netgear. I dare say what is old is new again, and we'll probably start to see some of the same with iPhones.
Sorry, just a quick one on that.
Yep.
The four-way handshake that you're talking about?
Yep.
Is that like when I come home from work, what my phone does with the device, or is it only the first time?
No, it's every time.
So when I come home from work, I get
or
home.
when you demorph it. But once again, someone actually has to be nearby, or
Or that thing.
someone needs to throw a Dropbox out.
Okay.
That might be what that other device I showed you was used. And the final one is around this rogue access point piece that I often think we don't do it right, and that's because if you look at most pen testers, they said 125 question exam called CEH, and they then have it posted on the title that's on par with CISSP and BC and OAM and all that shit. So I do have an issue with where we put pen testers in that space. So sorry for anyone who is a pen tester who's done their CEH.
CEH on the way.
Say,
Okay.
all right, whoever's banning the bad cat. But it's actually we don't consider a lot. Everyone, actually, a lot of organisations skip over this man in the middle piece. And that's always interesting. Even encrypted packets as well, we can start deducting things such as who's in range, who's actually connected. You can start doing, so there was a client I've done some work for in the last few weeks, where we're actually starting to do pattern of life analysis based on the activities that were taking place. Denial of service conditions, there's some really cool commands using the existing aircraft suite. But another one that's been really interesting that I've been playing a lot with is, I've been playing a lot with my own isolated environment, not affecting anyone else, in what I call layer 1 denial of service conditions. That is, take my hack RF and just jam. For the simple fact that that process alone will bypass intrusion detection and intrusion prevention systems that are set up to detect. It's awesome. Because you think about it. You go over to Macquarie Bank, and all the traders have come in after a long night out at 10 a.m. at 9:55. We're about to hit the trade button, and you're jamming their Wi-Fi with about $300 worth of kit. Hypothetically, of course. Hypothetically. Say again. So in terms of client-side attacks, interception as well is always a big one. One of the things I'll probably go through a little bit later today is engineering. It is engineering an outbound connection between your own device through a VM and then allowing clients to join a rogue access point, off the back of which you can then start doing man-in-the-middle attacks, even against SSL. A test we did recently involved extracting like API keys against some IoT devices. Another one we had as well was using the responder toolkit to extract end-to-end creds as well over a rogue access point.
As soon as Windows connects to a new network.
Yeah, so it starts doing SMB requests in this case because we thought it was connecting to the client network in a WPA2 environment with a pre-shared key. We just fired up the responder and we started getting creds out.
And owned everything.
Everything that user had access to, we had access to. So, thankfully they were only the business development manager. We just had access to client records and stuff. And then, other things there is, this doesn't, something that really, if I haven't talked about enough things that ship in this industry, the whole piece on looking at client-server architectures and using that for some sort of management science of, well, this is how long it's going to take because it takes 0.6 hours to pen test one IP address. This doesn't fit into that. So if you think about it, devices are constantly calling out networks. And this is always a cool one. Can we start coercing connections off the back of those devices? Well, look, open networks, certainly. And when it comes to web and WPA2 environments, you kind of need a password. Whereas if we start looking at WPA and WPA2 environments using enterprise creds, especially those using username and password-based authentication, there's usually a good chance of success. The clients will actually need to validate the cert from an access point, and Android doesn't do this by default. Apple, on the other hand, does, and even still, we have seen this where we can actually start socially engineering a connection of a user because the cert vaguely resembles the environment they want. And if you think about, this is why it's cybersecurity as opposed to IT security, because you can actually start interacting and manipulating with human beings. If the user starts going, okay, well, it sounds about right, I'm just going to click through the cert because I actually like my internet. And that's the case there. 802 and AC I really haven't been playing with, just because there hasn't been a need for us to do so yet. But if you look at it, it does come back to, does anyone know when we got rid of web and open networks?
Still,
I've seen web.
there's one right here.
Oh,
Yep. Right now, it's not even hacking; it's just natural selection.
Yeah.
There's a hidden web network that you can get right in the room.
That's not one of yours.
Nope.
So how do we set up rogue access points? I'll reinforce. I'll reinforce Nuble's comment before.
It's 100%.
This isn't about turning up with a pineapple in gold chains and you post normal industry certification. This is about actually going through and troubleshooting problems and you start fleshing them out. So all of a sudden my access point's not working. All right, let's go back. Let's actually fix it. Okay, it's still not working. Let's go back. Let's actually fix it. This is something I really like. Sort of throwing these problems at a lot of my students at Alfa is they actually have to start working out why something doesn't work and understand fundamentals off the back of that. And for me, this is kind of why we hack. We hack to learn. We don't learn to hack. We do this to actually understand what the heck's happening. So if you are going to tag in tonight, one thing I'll really hammer home is actually do some troubleshooting as you go through. So a couple of tool sets out there. Mana Toolkit was released by the guys from Centerpost out of South Africa. It's pretty easy to set up just using the Alfa cards. I did manage to bring in a couple of these if anyone would like to have a bit of a play tonight. But yeah, all you need is a couple of these Alfa. It's just one of these Alfa cards, $50 off eBay. I'm not too sure if they're still selling them off OzHack. But yeah, straightforward, easy to get underway. Each of them has an individual component, which will take a bit of time to actually get set up. But you've also got portals for conducting social engineering attacks as well. And then you have Metasploit that fire up as part of it. But the actual scripts themselves are fairly easy to read through, so that when you actually have to deviate and start making your own content, it's pretty easy. The other option is an inbuilt tool with Linux and a connection editor, which allows you to create a hotspot just by clicking through. Yeah, because we can put these cards over to hotspot modes, it's pretty easy, and then modify security settings if we have to. Actually, because the nature of the Alfa cards, to actually increase our power of the cards to a point where we actually become far more attractive access point than say the real point. as a general rule of thumb, amping it up starts to be a little bit problematic, but if it's part of a sanctioned test, it's not really too much of an issue at all.
Problematic legally, or
It's more so if we have a look at the ISN pairs, so 2.4, 5.8, 900 megahertz, and L is a 433 to 435 megahertz, I believe the transmit power is 20 dBi off the top of my head. It's not a particularly loud one that we can transmit at, because we actually set our transmit power a lot higher.
it'll mess up a lot of stuff.
It has the potential to. It's really about it's really more of Wheaton's law here. Don't be a dick. Important thing to note when you're using any of these tools. Wireshark is phenomenal for when you're doing troubleshooting, or as I had in my class last week or the week before, taking students through Wireshark and capturing traffic off their own mobile devices is really eye-opening. Funnily enough, Chinese students don't realise how much stuff they're actually sending in the clear because of the Baidu and a whole heap of other apps they have on their phone. Being able to Nmap devices is also pretty cool, and even just doing some other basic tests as well. More so with an interesting one with Etiquette is more so from a client to an access point you're attacking and being able to modify things too. So really, this is getting kind of to the end of my talk. Two things I was keen to go through was firing up a couple of Rogue APs and just using the Mana toolkit, and just doing a walkthrough of what one of those Rogue access points looks like off the back of Mana, and then and setting it up properly. Just one thing to highlight when you are using Mana toolkit: make sure you set enable Mana to 0, or otherwise everyone authenticates to it, and that can be a bit criminal. Just a little bit. And then NM connection is a really simple tool that you can use to start practicing Rogue access points. And even because you're on Kali as opposed to a dedicated piece of hardware, you can start doing proper network traffic captures and really start probing the devices properly. That's the easiest way to get in touch with me. The QR code is trustworthy. Otherwise, I will be here with the cards to play for a bit if anyone wants to start going through things. Otherwise, any questions? Bueller? No? Cool. All right, guys, thanks for coming out tonight. I'm really looking forward to contributing and participating and even learning a bit of everyone over the next few weeks. So, thanks again.
Thanks, guys.
No worries.
So, does anyone keen to play with the Rogue APs?
Yeah. Cool. I might just go to the bathroom first. Otherwise, the cards are there. Just give me one. Yeah.